The ocean takes up majority of the Earth's surface. This equates to having a lot of areas to actually look through if you are ever looking for anything on the seas. As the world becomes more globalized, shipping traffic has grown rapidly to support the economic activities such as transportation and cargo movement. However, the rise in shipping traffic has caused other problems such as environmental degradation, piracy, and illegal fishing. Companies like Airbus have developed technologies to monitor the seas and allow users to detect any unusual shipping activities with their monitoring products. Thus, it is easy to see why it is useful to have a machine learning model that can identify ships quickly and accurately. The machine learning model we are using to detect ships is a form of neural network, which is in a nutshell a bunch of layers, let's call them learning layers, that learns the patterns of its inputs. For each pattern learned by a layer, a feature that can be used to identify a ship in the image would potentially be discovered. To be more exact, the model our group is using is called UNet. What UNet does is it passes the image through a few of these learning layers, after which all of this information and image is downsampled. Or in other words, they are downscaled and further simplified based on certain features which can then be used to easily identify if there's a ship or not. This whole process is repeated for a few layers as you can see in the image. The special part about UNet is that after all this passing through of learning layers and downsampling, the image and information is then upsampled again. In order to account for the drop in clarity of the information and image, UNet concatenates the input with a higher resolution image that comes from one of the few iterations from the downsampling process, as you can see from the grey arrows. This juxtaposition between the post-upsample and pre-upsample image and information is what helps UNet learn the image and detect features better, since it has a more relevant and accurate comparison. Moreover, the upwards layers of the upsampling process of the image will help to get back information that was previously lost, such as the location of the pixels that contain the ship. Of course, after using a model, we have to test the accuracy of it. Our group went with a method called mean average precision, MAP for short. We first calculate the intersection over union, or RUU for short, which basically measures how much area of the predicted area coincides with the actual image area. The greater the overlap similarity, the higher the accuracy. Just like all accuracy measurements, there are false positives. We set a threshold to determine if a match is good enough. If the IOU is above the threshold, we say it's a true positive, if not, it's a false positive. The precision is then calculated as the ratio between the true positive and the sum between the true and false positive. Using different thresholds will result in a different average. Each average precision is for one data point, so by getting the mean across all of them, we get the MAP. In our efforts to improve the map score, we aim to make some tweaks to the dataset and algorithm. An issue with our dataset is that majority of the images show nothing but clouds and the ocean. As such, one of the ways we went around this is to refine the dataset such that the proportion of these images with images that contain ships are improved. On top of this, we also augment the image by brightening them up and changing the orientation to help the model better detect and learn the patterns of detecting ships and images. As for the algorithm, we explored the effects of tweaking the parameters of the UNet model, such as changing the optimal number of steps needed for training. And after all the tweaking of the dataset and algorithm, we were able to see an improvement in the map score, which translates to better performance in terms of detecting ships. As can be seen in this slide, our final model is able to segment the shape of the ship in the images decently well.